Okay, so in this video, we will go through the Cisco packet tracer. So I'll be posting these instructions on how to download and get your account set up in Cisco packet tracer. You can follow them. So basically, okay, so this is the link and also post that link here. So this is the link from which you can get the Cisco packet tracer. And so that's basically posted in the Network Academy at Cisco. And so once you go through the installation process, let me post this again. Once you go through the installation process and launch the packet tracer, you will be seeing a login screen. If you have not used that packet tracer before and you don't have a Cisco account, you have to create an account with the Cisco Network Academy. And they have two login options, but they basically recommend you to use the green skills for all button, that option to log in. And again, that requires a user account. So you create an account in Cisco Network Academy, you will get a confirmation email, go through the typical account setup process, and then you'll be able to log in using that skills for all page. And once you can by default, I think it will let you to stay logged in. So it's up to you if you want to choose that option so that you don't have to log in each time. It's manually. And then you should be able to open the Cisco Packet Tracer, the application, which is kind of looks like this when you open it. It has two levels you can work on. One is a logical level and the other is a physical level. We'll be using primarily the logical level. Physical is like if you want to set up like an office with all the rack and everything, you can do that. Again, once you know how to do it physically, it's just the same idea, but you have to do it. So once you know how to do it logically, it's the same idea to do it physically by just setting up the rack and the switches placed in different rack, the computers placed on some other rack and so on. So you won't be spending time on how to set up the rack and everything. We'll go through the logical level in all the assignments. So this is kind of the main screen, and so at the bottom you have the different devices. So if you let me make sure it's recording. So you have, say, first the network devices. If you click on it, you see the routers, switches, and all on the bottom tab. And for each device, you have different versions or different kind of devices with different configurations. You can use primarily anything unless I specify you to use any particular model of the router or switch. So we'll stick on to some models for consistency for switches and routers. Similarly, you have end devices like PC, laptops, and so on. And then you also have connections. You can use this option. So this will automatically choose for you what connection you need between different devices. For example, you need different types of cables to connect different devices. So if you want to connect two computers, you need one type of cable. If you want to connect a switch to a computer, you need another type of cable and so on. So you don't have to worry about what type of cable you need to use. So if you choose this option, it will do that automatically for you. Otherwise, you can go to a specific type of cable like a straight through or crossover and all these other types of cables, and then choose what needs to be used to connect. But again, that requires more extensive knowledge on cables, network cables, which is again not the focus of these assignments. So we'll just use the auto option, so that will automatically select for you the type of cables you need. And then you can also play with this by default. It will whatever you do will be in scenario 0. But if you want to, just so it's one packet file, but if you want to create different scenarios for different setups, then you can create new and then it will create a scenario 1 and so on. We'll again keep it simple. For each file, we'll just use one scenario. And so if you want to use multiple scenarios, I'll mention that as needed. Okay. So what I'm going to do is, so in the lecture in module 4, we covered VLANs. So again, VLANs or the um, layer 2 construct for subnets, which are in layer 3. So when layer 2 constructs, it means we can use switches to connect the devices, the computing devices like laptop or PC to a switch, layer 2 switch. And then you can use the layer 2 switch to communicate within the VLAN. And VLAN offers you a separate broadcast domain. So like subnet offers a broadcast domain in the in layer 3. In the MAC layer, layer 2, VLAN provides you its own broadcast domain. So that means any broadcast message sent within a VLAN just stays within the VLAN. It doesn't go to other VLANs connected to the switch. So you could connect more than one VLAN to a switch, as we saw in the slides. And the connection from a computer to a switch will be called the access mode of connection, and connection between two networking devices are typically trunk mode of connection. So it means the access mode of connection, they'll be carrying traffic from the computer to the switch, and a computer will be assigned to a particular VLAN. So only that VLAN messages will be going through that link. Whereas in the trunk connection, you basically, the trunk links can carry messages belonging to any VLAN. Okay, so we'll be going through these three examples that have listed in the slides, how to set them up, and you can use this as a basis to go, do the assignments. Okay, so let's do the first example, which is called the router in a stick model. So here I have one switch to which I have two computers belonging to VLAN 1 and two computers belonging to VLAN 2. And so in order to communicate within the VLAN, one computer can send a message to a switch and switch will forward to the other computer after going through what is called the address resolution protocol, which I have not explained yet because we'll be covering that in the next module 6. But basically, in address resolution protocol, the switch will get to try to find out what is a MAC address for a device with a particular IP address. So it will do broadcast, but since you are now setting it up as a VLAN, the broadcast will be limited only within this VLAN. And the device that has a corresponding MAC address for an IP address will respond back to the switch, and switch will forward to the sender. So for example, if this machine wants to know what is the MAC address of a device with this IP address, it will initiate an ARP broadcast message, and the message will go to the switch. The switch will forward that message only to this other devices within the same VLAN as well as the router. Only that device that has a corresponding IPS address would respond back with an ARP response. It has a MAC address of this device, and the switch will forward back to the initiator. So that way, this initiator will get to know the MAC address of the destination and will then initiate a data message that it really wants to send to that particular destination. So that's how devices find out the MAC address of the machines with a particular IP address. But on the other hand, if you want to communicate from this VLAN to this VLAN, so there are two different VLANs. So we cannot do that simply using a layer 2 switch. So this is a layer 2 switch here. So you have to go through a router. So that's why I connect this switch to a router. So when say this computer here with 10.10, let me zoom it, wants to forward a message or send a message to this device with IP address say 192.168.20.10, then it will send the message to the switch. And again, each device will have also a gateway router, which is the default router IP address to which the device has to forward a packet. So for each VLAN will have a gateway router IP address. So for this 10.10, 10.11, I put them in this subnet with a subnet mask of 255.255.255.0. So if you try to get the corresponding subnet address, it will be like 192.168.10.10. You do a bitwise and with 255.255.0. So what you get is this 192.168.10.0. So this is a subnet address. So, and the subnet mask of 24, the last 8 bits are located for the first part. So that's why we use this 10 for the first part. That will be the IP address of this device here. and 11 will be the IP address of this device here. Now, for the gateway router that belongs to this subnet, you can come up with 192.168.10.1 because again, the last 8 bits you can assign anything unique, and this is what the first available IP address that can use for the host part is typically what we assign for the gateway router. So we'll use this for the gateway router. Similarly, for this VLAN on the other side, I have mentioned the what do you call the subnet address to be 192.168.20.0 with /24. That means again last 8 bits allocated for the host part. So the gateway router could begin with something like 192.168.20.1. So that will be the IP address of the gateway router for this subnet. Okay, on this VLAN here. So subnet VLAN are going to interchangeably use because as you know that it's basically a layer 2 and layer 3 for subnet and layer 2 for VLAN. All right, so first we'll start with a single router. We'll still see how we assign two gateway router IP addresses to a single router. We'll do that primarily using sub interfaces. So each port is called an interface. So the switch has multiple ports or interfaces, and we'll be connecting the computers and the routers, everything to each of those, one of those interfaces. And we'll be then configuring those interfaces as to whether they're going to carry access mode traffic or trunk mode traffic. So let's get on to this assignment so that we can do things right away. So let me first click on network devices and switch the second one. So again, these are here at the bottom. So then we use a 2960 switch. So click on it and place it here. And we need one more switch. So click on 2960 switch again. So it becomes like a red circle with a cross. So once you have clicked it, so you can place it here. So let's first set up this VLAN on this side. So now we need the end devices. So click on end devices. Click on the first one, end devices, and the PC here. And click here. Again, select PC and click here. So we want to have two PCs. Now we can also do some text recording, text message information here. So this button can be used. So click on that. So with that, you can type some text. So VLAN 1. And also you saw in the slides, the default VLAN number is 1, but VLAN numbers can go from, I think, 1 to 1004. So we'll use the default VLAN number as it is, and for the other VLAN, we'll assign VLAN 2 as the number. And the VLANs have a number as well as a name. So what I have typed here is VLAN 1, which is the name, but the number is just a numerical value 1, 2, 3, and so on. And we want to have this VLAN with subnet address 192.168.10.0.24. Now let me see if I can make, okay, so to come out of this text field, you can click on the first button here that will make you come out of anything that you're working on. So let's go to options, preferences, we just set the font size. So let's see, we can make it a little bigger so that things are more visible. Let's see. Yeah. Okay, so things are more visible. The screen space will reduce. I think, but this will be helpful too. All right, so so now we can use this connection and click on here, and let's start with the first computer. So this is PC 0. So click on this and drag it to this one. And click again on this. So this is the auto cable I said. It will automatically choose the type of cable you need to connect a PC to a switch. You don't have to worry about the explicit type of cable you need. So it will automatically choose. Okay, so let's go ahead and assign the IP address for each of these devices. So this is 192.168.10. Again, this is just text, but still for reference, we need to correctly have it. Now the gateway IP address, if you want, you can also record that as well. So the gateway would be 192.168.10.1. Okay, that's the gateway IP address. That means the IP address of the gateway router. All right, so let's click on this device. Now go to desktop, IP configuration. So the IP address we want to assign is static. We don't want to go through DHCP for now. Just statically assign the IP addresses 192.168.10. Say 10, and that's what I had in the slide. So then the subnet mask will automatically come out to be 235.235.25.0. If you want to change it later, something else in somewhere assignment, we can do that. You could do that as well. This is a default gateway router I want to assign for this subnet. It is 192.168.10.1. So you don't have to save anything once you type. I think it's automatically saved. Just click the cross and the top right. So do the same thing for this PC. This, okay. Desktop IP configuration. So that's 192.168.10.11. So that's the other IP address I want to create. And the same gateway IP address and then .1. So click OK, this. And then for this switch, we'll connect again two end devices, say a PC here and a PC here. We use the cable, this one, automatically choose the cable connection type, click and then drag, and click and then drag. So we can copy this text and change things here. So here it's going to be 20.0 and 20.1 is going to be the, okay, if you click it somewhere else, that checks speed reference. So to come out of it, click the first button, so it will make you come out of that frozen button. Okay, so let's configure the IP address of this laptop. So this is 192.168.20.10 with that IP address, subnet address, and then the gateway is 192.168.20.1. Okay. Then for this one is 192.168.20.11, 192.168.20.1. So if you now place the cursor on these devices, you will get to see the IP address that you just configured and the gateway router as well. Similarly, for this device, you get to see the IP address and gateway router. Okay, so now let's set up the interfaces. Now, if you click the, or just place the, don't click, just move the cursor, goes to the green triangle, just move the cursor on the top of it. You don't need to click it. You will see the different interfaces. So we connected this, so okay, let me just, okay, so this is what I want you to see. So this interface is specifically FA01. This interface is specifically FA02 on the switch side, okay? Then here again, for this switch, it is FA01 and this is FA02. So to be just easy to follow through, for first PC 0, it is FA01. For next PC, it is the next interface. So connect the PCs in this order. So they also get connected to a switch in the same order, FA01, FA02, and so on. Okay, so let's go to the switch. So we want to, okay, so this has to be VLAN 2, right? So this side is VLAN 2. Well, let me see, this is different from this. Okay, that's actually the second setup. Okay, so let me do the first one, which is just one switch. Okay, with one switch, we don't need actually this thing. We can select and delete. So we can actually connect the other two laptops to the same switch as well. So let's do that. Okay. So of course, the PC numbers would be not 2 and 3 because I created and deleted them. That's okay. So let's connect these PCs. Yeah. Okay, so these are still VLAN 2. So these two are will be VLAN 2 according to the way we are set up. So let's set it up. So this will be set up the IP address here. So the computers don't need to know what VLAN they are part of. That's something you have to know. Only the switches take care of those interfaces and set up the VLAN numbers. So it's 192.168.20. Say 10. 192.168.20.1. So that will be for this PC. And for this PC, is 192.168.20.11, 192.168.20.1. So these two are in VLAN 1, these two are in VLAN 2 with this IP addresses starting with 20.10 and 20.11 for this. The gateway is 20.1 for these two. Okay. So gateway router is the next hop router to which these devices will forward the information. So now if you click on the cursor here, let's place that. Don't click, just place it. It's 1, this is 2, hopefully this is 3, yes, and then this is 4. Okay, so now let's go to the switch, click on the switch, and go to the config tab, click on the VLAN database. So by default, they have only 1 and these other VLAN numbers. So you want, we'll stay with that one for these two computers for VLAN 1. We could not rename it as VLAN 1 because that's a setting they name it as default. So let's stay with that default name. But we know that that's VLAN 1. So let's create the second VLAN, just type VLAN 2 and whatever name we want to create for that VLAN. So in this case, VLAN 2 and click add. So that will add VLAN number 2 and the name that you just entered on the switch. Now, these interfaces, 1, 2, 3, 4 are the ones that we have created so far, connecting these computers to these interfaces. So we want to put interface 1, this one. It won't show because I opened this, but these two, 1 and 2 belong to VLAN 1. So, and if it automatically, by default, all the interfaces will belong to VLAN 1. So we can let interface 1 and 2 fast Ethernet 1, 0 slash, everything will be 0 first, slash 1, 2, 3, 4 like that. So we can let 1 and 2 to be in VLAN 1, but 3 and 4 are these two interfaces for this VLAN 2. So we want them to be in VLAN 2. So let's go back and we'll click on fast Ethernet 3 and put that in VLAN 2. So for access connections, you can be in only one VLAN. So we'll put fast Ethernet 3 and 4 in VLAN 2. So click on somewhere here so that you come out of that pull down menu. And then fast Ethernet 4, you click here. It's in VLAN 1. We can make it to belong to VLAN 2. So the interfaces 3 and 4 at the switch will now carry only traffic belonging to VLAN 2. So you see it goes through a kind of configuration process. So the colors will change to red, green, yellow, orange, and then eventually it will turn green once everything's set up and it's running. Now we can close the X bar on the top. Now with this we can communicate just within the VLAN. Let me try it. All right, for that, we click on the computer and go to the command prompt here and click on the command prompt. And then, so the way we're going to test the communication is using the ping command. The ping is a command that you can use to test if a computer on the other side is alive running. So you can ping using the IP address. So we are going to first ping only within the VLAN. Now, before we do that, make sure the real-time option is chosen. So we have two options to go through this process. We'll not be using simulation. We'll be just using the real-time option to go through the process. So click on the, make sure that real-time is clicked. I'll show you some cases how the simulation works, but we'll just use real time because that's where you really see the reply coming from the other side quite quickly. The simulation will go through a long waiting process of different messages underneath that are being sent. We can do it once or twice, but not for every time. Okay. So we'll make sure the real-time option is clicked. By default, that's what is chosen. So make sure that is chosen. And now click on the computer, go to the command prompt, and then say ping the IP address 192.168. So I'm doing it from PC0, which is having 10.10. That's what we configured. So let's do 10.11, which is the other PC, PC1. So that its IP address is 10.11. So that's what I'm doing the ping. So you should be able to get the reply from this computer here. Okay. Now, if you want to communicate with a computer in some other VLAN, as I said, we cannot go through this layer 2 switch. So that's when you need a layer 3 device, a router. So the first device listed below is a router. We'll be using, say, the 1941 router for most of our purposes. That's sufficient. So you can click the router and place it here. And we're going to use just one router. So that's why it's called a router in a stick model, like a stick attached to a stick. So click on the cable, again, connect this cable switch to router, just drag it in. So again, use the auto selection option, so it will just choose whatever cable is needed. Now click on the router and again go to config tab and go to the VLAN database. It also has only the default VLAN entry. So now let's create VLAN 2 information. So the VLAN number is 2 and VLAN name is 2. Just click add. Once you do that, go to, so if you notice here, this interface of the router is gigabit Ethernet 0/0. So it's basically this interface here, 0/0. So we have not used the other interface. So this router has only two interfaces, and that's sufficient for us. We just need one interface for this assignment. So the other routers listed here, as you increase the model numbers, you'll get more interfaces. So click on this interface 0. So now, as I said, we want to create two gateway router IP addresses, but still have only one router interface here. So typically we use sub interfaces to create, to assign a unique gateway IP address for each VLAN. So click on the 0/0 interface and click on now the CLI, which is a command line interface window. So you could see a kind of like a DOS window where you can really enter some command to set up things. So that's what we'll be doing. So in whatever stage you clicked on this screen, so I clicked on interface 0/0 and then you click CLI. So you'll be in that interface now. So I want to create in this interface two sub interfaces. And the way you do that is you can type interface in full text like this, or just use INT, means interface. Then G0 so everything is, see, even if you go back here, everything is G0, G0. So after the slash only, you differentiate the difference. So these are the physical interfaces. This is 0/0, which is basically interface 0. This is interface 1. So within that physical interface 0, this is where I want to create a sub interface. So I say interface int G0, which is there for everything, slash. Now, this is the interface 0, the physical interface. For that physical interface, I want to create a sub interface. I call it as 0.0.1, 0.1. We'll say 0.1 to make it better, because 0.1 doesn't mean like it's decimal value. So it is like within the physical interface 0, I'm creating a sub interface 1. So it's 0.1. So typically, we'll try this to keep track of things easily. We will follow the convention of assigning the sub interface number to be same as a VLAN number. Okay, they could be different. They don't have anything to do with each other, but just for us to easily follow two things, we'll assign the same VLAN number that we have for that subnet to this interface, sub interface as well. So each VLAN will have a gateway, particular gateway IP address, and that gateway IP address will be configured for a particular sub interface at the router. So we are now, so this is a command to create the sub interface. So within that interface 0, you go into that. That's why I said you just click on interface 0 in the config tab, and now click on CLI. It will automatically take you inside that. So then this is a sub interface creation command. So int G0, which is for all the interfaces, slash 0. So this 0 is the physical interface 0.1. So created it. So now you see sub interface will be the sub interface 0.1 now. Now we want to assign the gateway IP address. So let's make it IP address 192.168. We created 10.1. Remember, that's the gateway IP address for VLAN 1. And then the subnet mask has to be explicitly entered. So it is 255.255.255.0 because it is 24. That's the subnet mask. Okay, so before that, I also have to encapsulate. So this VLAN, this subnet will be carrying the VLAN 1 traffic. So I have to enter this command called encapsulation dot 1Q dot 1Q1. So this is again the command syntax encapsulation dot 1Q. And this one has nothing to do with the VLAN number. For all the sub interfaces, we'll use dot 1Q. This is where you specify the actual VLAN number whose traffic this will be forwarded to this interface. Okay, so you do that. And then you can say no shutdown. So that means you don't want this sub interface to shut down. You want to be up and running. So this will make that thing going on. So now what we want to create is the second interface corresponding to this gateway IP address. So still within that physical interface 0, we are you can exit if you want to. Now you're back to the main physical interface. Now you can say int G0/0.2. So again, within this, so again, G0 for every interface, physical interface. This is the actual physical interface number 0, and this is the sub interface number .2. So you do that. So now you're inside the sub interface 0.2. Now you can enter these two commands in any order. So let's find. Typically we do the encapsulation first. So encapsulation dot 1Q2. So that's now going to carry VLAN traffic for VLAN 2. And now we can set the IP address as well. So just follow this ordering, the encapsulation first and then the IP address. It shouldn't matter really what order you enter either to the two of them, but just follow this one. So it's 20.1. That's the gateway IP address we created. And then it's 255.255.255.0. That's a subnet address, subnet mask actually. Then no shutdown. So no shutdown. So shutdown is one word. So then you can close it as it is. So when you do that, you still see the red mark. So one thing that will be catchy thing is go back to config, click on the gigabit Ethernet 0. By default, the port status will not be on. So make sure you set it up to on, you click on so that the port, the main interface, it's on and running. So now it will go through the setup process and trying to turn green. Now, if you place your cursor on the top of the router, you could see the two sub interfaces that we just created. Under the main interface 0/0, you could see the 0.1 and 0.2. Okay, it seems that the first ordering doesn't work. So let's go back to the first interface. So you have to go through the encapsulation first. So let's go to interface 0G0/0.1. So I'm inside that sub interface. So first encapsulate that traffic. So first do the encapsulation command like we did for second subnet. So encapsulation dot 1Q, then enter the IP address. So I think I said the order doesn't really matter, but I think it does matter. So 10.1 and 255.255.0. So let's follow this ordering. First, create the sub interface G0/0.1. So that's the main interface dot the sub interface number. Then you could do it anytime, any number of times, that's fine. Now inside the sub interface, create this and then this IP. So again, this is encapsulation, so keyword dot 1Q is also a keyword. This is what is going to be different. 1 for VLAN 1, 2 for VLAN 2, and so on. Then the IP address of the gateway router 10.1 and the subnet mask. Then you can press enter and say no shutdown. So this should be fine now. So now if you place the cursor there, you can see its IP address is also showing up. So let's follow the convention of creating the setting the encapsulation first and then setting the IP address. Okay. All right. So with this, you should be able to communicate from a device in one VLAN to another VLAN. So let's do that. So already have the command prompt open. So let's ping 198.168.20.12. Not 12, 11. We have only 10 and 11 in this VLAN 2. So let's say 10. So the first time you may get a reply request timeout, but you should be able to communicate just to switch and the router and then get back. Okay, there's one thing that you have to do, which I didn't do. So let's see. Now go back to the switch. If you click on the switch, this interface 5 with which it's connected to the router, right? So this is fast interface, fast Ethernet 5, which is connected to the router, has to be trunk mode from the switch to the router. So unless you set up the connection from the switch to the router in trunk mode, you'll not be able to forward traffic across VLANs. So that's what happened. You're not able to communicate from one VLAN to another VLAN. So make sure this interface that you're using to connect the switch to the trunk, to the router, is set up in trunk mode. So by default, it will be in access mode, but you have to set it up to change the fast Ethernet 05. That's the interface you're using to connect to the router. So set it to trunk, then click on this VLAN pull down menu. You can see all the VLANs will be selected. That means this trunk mode connection can carry traffic belonging to different VLANs. So that should be fine now. So let it get set up. So let's try this again. So we'll ping 20.10 now from VLAN 1 from this. Let's see, we should be able to get the reply now. Yes. So it takes some time because, as I said, they'll try to find the MAC address of the destination by going through the ARP process and so on. So it will take some time, but eventually, for next time you run it, you'll be able to get it right away because once they find the MAC address, they store in a cache. And next time, whenever they want to communicate with that machine, all these devices will take the MAC address from the cache and right away use it. They will not go through this ARP address association protocol to find the MAC address for a particular IP address. So let's close this. Let's now communicate from this PC1. We have not done that yet to this PC5, which is 20.11. And for that, I can show you the simulation mode. So let's say now this is where you can choose a packet to be transmitted. So click on that kind of envelope kind of thing button there. Click on that and click on this PC1 and click as the sender and PC5 as receiver and click on simulation and you can also filter all the events. We don't want a lot of messages to be going around. Let's see. There should be a way to filter since I increase this. Okay, so there's an edit filters. So let's remove all the unwanted protocols. So you need only ARP and ICMP. So now click this arrow. So you will see now PC1 wants to communicate with this PC5. And it will try to reach the router because it's in a different VLAN. And this switch will then try to contact PC5. It looks like it has already found its MAC address. So it will just be a unicast message. And then the PC5 will reply back to the switch. Since it's again across VLANs, they have to go through the router each time and then come back to the switch. And now the reply will come back to this PC1. Okay. So that's what will happen. So successfully requested and transmitted. So you can make it stop, like pressing this or dedicated triangle button again. Now, let's try now from this PC. Let's add a new PC for which we will not have a MAC address right away. So this is successful. So you can delete if you want this thing showing up there. Let me reduce the font size a little bit. Leave it there. All right, so we can do two things now as an extension. I can set up a PC within the same VLAN or create actually a new VLAN. So we'll do both. Let's do first the first thing. So I'm going to create, add a PC to this VLAN itself. It's PC6 by label, but we need an IP address for it. So let's set its IP address to, it belongs to VLAN 2. So far we have 20.10, 20.11. So this one, again, go to IP configuration for that purpose. So it's 192.168.say20.12. And the gateway address is 192.168.20.1. That's the gateway router for this VLAN 2. It doesn't change. Only the IP address of the device changes. The gateway router IP address is just for this router. So for all these PCs in VLAN 2, that's going to be the IP gateway IP address 20.1. Okay. So now let us set up the connection. So this, so I'm connecting this to switch. Now this is going to be, if you place the cursor there, this is 0/6 interface. So let's go to that. So already we used interfaces 1 through 5, 1, 2, 1 and 2 are in VLAN 1, 3 and 4 are in VLAN 2, 5 is actually a trunk connection connected to the router, and 6 is now going to be again in VLAN 2. So let's make it belong to VLAN 2. Okay, so we have set that up, and the switch port status by default on. So only the router status is by default off. So we have to explicitly make it on. So this PC is now basically connected to this switch. So soon this will turn to green arrow or green triangle. So let's now run the simulation. Okay, because it's in simulation mode, it won't turn green. So that's why it will be sometimes confusing whether it's turning green or not, or connection be set up. So once you make it real time, soon it will turn green. Anyway, so let's try back to go to simulation mode and see if this device, say PC0, is able to communicate with PC6. Okay, so simulation mode is on. So edit filters, only these two protocols are up and running or are turned on to run. So let's click the packet. First place it on sender and then on the receiver and click on this button. So this guy doesn't know the MAC address of PC6. So it first sends to a switch. The switch itself doesn't know, and it sees that it's in a different VLAN. So it will ask the router. The router will say it's a different VLAN. So the switch is now going to kind of do a broadcast to, now this connection has not been set up yet. Let me try to fix it 1 second. It's not real time. Since access VLAN 2, okay, it's green now. So you should be able to go through the process. Let's do that again. So you have to wait for it to turn green. Okay. Let's see now what happens. So the switch doesn't know the MAC address of this, and actually it's a different VLAN, so it has to go to the trunk connection to the router. The router informs that it is in VLAN 2, so the switch will now be broadcasting. See, now the broadcast happens only within this domain, and these two devices drop that broadcast message because it's not meant for them. It's trying to find the MAC address for this PC using its IP address. So it will send its MAC address to the switch, which will again forward to the router, and then come back and then go to that particular initiator. Okay, so I'm not sure whether that happens. So, okay. It has come back to that initiator. Why it failed? Okay, it will probably go through this again. So those are different trials to find out. You see the request timed out thing, because we actually want to ping from this machine to this machine. So a couple of times the request will time out. Eventually it will work. So that's why simulation mode takes a lot of time to wait, and you have to really see all this failure messages sometimes that may kind of be make you wonder what's really going on. But if you correctly set up things, you should be eventually running. So let's stop it and go back to real-time mode and just ping from this PC to this PC6. So this IP address is 20.12. That's all we need to know. So go to command prompt. So you want to ping 192.168.20.12. You see the reply coming. So sometimes the simulation mode will lead to some failures, which will again delay the process. But the real time, you should be able to get the result quickly, which is appearing on the screen. So we just want to be able to ping and see if it's running. Okay, so that's how you connect a new PC to this existing VLAN. Now within this, so from this PC, you can try to ping to something in the same VLAN if you want to, or yeah, let's do within the VLAN. So to 20.10, you should be able to get the reply, or to this 10.11, this PC1. So let this just do 10.11. The reply is coming from that PC as well. So everything is fine. So let's now set up a third VLAN just for practice. So I need to create a third VLAN. So let's make it somewhere here. Here. So we just need the end device. So let's do that here. So these two PCs belong to VLAN 3. And I'll make it 30.0/24, and the gateway is 30.1. Okay, then click on this to come out of this window. And let's connect these PCs to the route to the switch. So click on the connection cable and take this to this, as well as I can click on this and be connecting this to this. So if you just place the cursor on top, this is at interface 7 for the switch, and this is interface 8 for the switch. So let's go to the switch, VLAN database. VLAN 3 is not yet there, so let's create the VLAN number to be 3, and the name is VLAN 3, add it. Then for interface fast 7 and 8, by default, they've been access and VLAN 1. We want to keep it access, but we want to make them to belong to VLAN 3. And then 8, this other interface coming from the two PCs, make it belong to VLAN 3. So we've done that. So also at the router, we want to create the VLAN database for 3, update the VLAN database for VLAN 3. So add it. So that's VLAN 3. And let's click on this. So again, I click on interface 0/0 and then the CLI tab. So it takes me to that. You see interface gigabit Ethernet 0/0. So it will take you automatically there. Now I want to create a third sub interface to host this third gateway IP address. So for that, int G0, that's always the case, slash, and this is for the physical interface 0, because there's only one interface which you're using. This is 0, the physical interface number, dot. Again, as I said, the sub interface number could correspond to the VLAN number, so 3. So it will be changed to straight up. Just press enter. Now, as I said, first write the encapsulation command first, .1Q, and then 3. So encapsulation .1Q3, that's the first thing to enter after creating the sub interface. So this 3, so again, as I said, .1Q is always the same command, but this number is the VLAN number. Now you enter the IP address. So let's follow this order. I think that's what is working. So IP address, IP space address, then 192.168.30.1, that's the gateway IP address. The subnet mask is 24, so 255.255.0. Then let's make no shutdown so that this sub interface is up and running. So if you click the cursor, not click, just place the cursor on that. So under the physical interface 0, we have now the third sub interface 0.3, and that was having a gateway IP address 192.168.30.1. So that should be good enough. We have set this already to trunk mode, so this is now access mode. I think everything should be fine. Let's try to ping from this PC here, which you have not used for ping so far. So this is PC1, that is, I think, 192.168.10.11. So I'm going to ping from this to our new device that got added. So that's this I think was 30.10. So let's ping to that. Let me make sure it is 30.10. Oh, I did set its IP address. That's what I was having doubt. Okay, let's do that first. We did set its IP address. Yes. So we need to set that IP address. So make sure you have set it. So 192.168.30.1. Okay, yeah, 30.1 is the gateway. So for this device is 30.10, right? So that's why it showed the error message. So you cannot set it to be 30.1, but because we already set it for the gateway route. So 30.10 is fine for the IP address, no other device. So you see, it checks for uniqueness. So no other device has that IP address now. So now the gateway address could be 192.168.30.1. So that's fine. So now this one would be again IP configuration. So click on desktop and go to IP configuration. So let me show. So click on the PC, click on the desktop tab if it's not clicked. If it's showing physical, it will be like this, the back of the computer. So click on the desktop, click on then IP configuration. So now enter the unique IP address you want, 30.11. That's the subnet mask. So the gateway is 192.168.30.1. So the gateway is always the same IP address. Okay, now this should be fine to up and running because already set up the sub interface for that gateway IP address. So we were trying to do from PC1, let's do from that. So command prompt. So now let's say we do it to 30.11. Again, the first time the request may timeout, eventually you should be able to get a reply. Yes, that's what happens. Now you could ping from say PC8 now, go to command prompt and ping anything out there. So ping 192.168 say .20. Let's make it to 10.11. Should be able to get the reply. You got 20, 10, 11. Okay, so let's do it for 20.12. Be able to get the reply. 20.10, we should be able to get the reply. Okay, so all devices were able to communicate with each other. Okay, so just again, let me create one more VLAN just to make sure you're very comfortable with that. So for that, let's say VLAN 4 is the new VLAN you're creating. Let's add two end devices for that. Let's do a PC here, another PC, say here. Can move them around a little bit. Okay, so I'm going to make it in VLAN 40. So VLAN 4, but it's going to be 40.0. Then the gateway is 40.1. So click on this to come out of that. So let's make sure to configure the IP address. So click on the computer, go to desktop. Click on IP configuration. So 192.168.40.10 could be the first IP address for this VLAN. And the gateway is 192.168.40.1. So 40.10 is unique IP address for that computer. And for this one, let's go to desktop IP configuration. 192.168.40.11. The gateway IP address is 40.1. So we'll do that. Now let's connect these two computers to the switch. Let's connect this one first. And just click on that and drag it. Click again on this cable thing, click on it and drag it. Okay, so it'll take some time to go through the process. In the meantime, click on the switch, add 4 to the VLAN database. And now, so this, let's find out the interface numbers. So if you click, place the cursor there, it's 9, and this is 10. So interface 9, pass it the interface 9, you make sure it belongs now to VLAN 4, and to 10, make sure it belongs to VLAN 4. Okay, and both are in access mode, that's good enough, access mode. So let's wait for these to turn to the green triangles. So then we can set up. Let's now go to the router in the meantime. So again, on this gigabit Ethernet 0/0 interface, you click that. Now click the CLI tab. You will be, just press enter, you'll be actually in that interface 0/0. Now we want to create G0 / again G0 for everything. It's a convention. Then this 0 after the slash is the physical interface number. We are in 0, the physical interface 0 dot. Now let's give the sub interface number same as the VLAN number, which is 4, and just press enter for it to up. And then write the encapsulation command first, encapsulation dot 1Q4, and then the IP address 192.168.40. The gateway IP address, .255.255.255.0, and no shutdown. Okay. So that should be fine, and they have turned green. So now you should be able to communicate from, say, this computer here, go to command prompt, ping to anything out there, 192.168.10.10. You should be able to get the reply. Okay, so once things turn green, I think the request is less likely to get timed out. So this is how you can create the router in a stick model. So I can save it. Let's see, video example 1. I'll try to post it in Canvas so that you can load the same thing and kind of practice it. Of course, you have to practice different topology setups so that you get used to how to set up the commands, and then you should be able to easily do it. All right, so let's stop with this for this video.